These two graphs are very unique, and the shape that it makes here and here are what we call parabolas, better known as quadratics. Hello, my name is Daniel J. Kim, and today we'll be learning about quadratics. Quadratics are basically these curved-looking shapes that look like U's, and these things are called parabolas. And parabolas take on a form in which the left side and the right side of a parabola are perfectly symmetrical through a midpoint, which would be about here, and also around here. Parabolas are created by equations called quadratic equations, and these equations almost always have the same form as shown. So this right here is called a quadratic equation, and it's ax squared plus bx plus c equals 0. The values a, b, and c are given, and so they are known values, and a cannot equal 0. And obviously x is the variable, and we do not know the value of it. To the right are some examples. So for the top equation, 2x squared plus 5x plus 3 equals 0 is a quadratic equation. The 2 represents the a value, the 5 represents the b value, and the c represents the c value. This follows the equation of this right here, so it is a quadratic equation. X squared minus 3x equals 0 is also a quadratic equation. For the a value, it's 1, however, we do not usually write 1x squared. Negative 3 is the b value, however the c, since we can't see it, that means c is equal to 0, but that still means it's still a quadratic equation. However, for 5x minus 3 equals 0, it is not a quadratic equation. Although we have the b value of 5 and the c value of negative 3, the a value is missing, which means that a is equal to 0. However, like said before, a cannot equal to 0. As said before, the standard form of a quadratic equation is ax squared plus bx plus c is equal to 0. However, not all quadratic equations look like that. For example, we have x squared is equal to 3x minus 1. This right here looks nothing like this. However, if you just subtract 3x and add 1 on each side, like this, then the new equation will look like x squared minus 3x plus 1 is equal to 0, which now matches this right here. And for this one, it looks nothing like this. However, if you distribute the h into the right here, you would get h squared minus h is equal to 3, and you could just subtract 3 on each side. And h squared minus h minus 3 is equal to 0, which also resembles the quadratic equation. Quadratic equations almost always have two solutions that are equal to 0, which is why there's a 0 right here. Although they usually have two solutions, there could also only be one solution or no solutions at all. In order to solve for quadratic equations, there are many methods. One method is by factoring the quadratic equation, by using the x method or the box method. Another way is by using the completing the square method. And the last way to solve for a quadratic equation is by using something called the quadratic formula. And the quadratic formula looks like this. It's basically x is equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Obviously, we can see that there is an a, b, and a c, which also resembles the a, b, and c from a quadratic equation. And so in order to use this method right here, you just have to input the values of a, b, and c into this right here. And the reason why there's a plus and minus right here is to show that there could be more than one solution. When we look at the quadratic formula, the most noticeable thing is this right here. This is the plus or minus sign, and it basically tells us that there could be two answers to the quadratic equation. However, sometimes parabolas could only touch the x-axis once, or the parabola could be way above the x-axis in which it does not intersect with it at all. So how do we determine whether it has two answers, one answer, or no answers at all? We use that based on this part right here. The b squared minus 4ac tells us how many answers there are to the equation. We call it the discriminant because it could discriminate between the possible types of answers. When you input values for b, a, and c, if b squared minus 4 times a times c results in a positive value, there are two solutions. When b squared minus 4 times a times c results in 0, we only get one solution, which is right here. However, when b squared minus 4 times a times c results in a negative number, you get a parabola that looks like this, in which there are no answers at all. So for our example, we have 5x squared plus 6x plus 1 is equal to 0, and we want to solve for it. Obviously, looking at this, it is a quadratic equation, and so we know so now we could figure out the a, b, and c values. The 5 would be the a value, the 6 would be the b value, and the 1 would be the c value. Since we know all of these values, we could input them for the quadratic formula, and so we get the x is equal to negative 6 plus or minus the square root of 6 squared minus 4 times 5 times 1 divided by 2 times 5, and we could just solve, and you get x is equal to negative 6 plus or minus the square root of 36 minus 20 divided by 10, and then we could solve for more, and we get x is equal to negative 6 plus or minus the square root of 16 divided by 10, and we now get x is equal to negative 6 plus or minus 4 divided by 10. When we get to this part, since we have the plus and or minus sign, we have to write two separate equations until we get x is equal to negative 6 plus 4 divided by 10, or x is equal to negative 6 minus 4 divided by 10, and we could solve for both of them, and so we get x is equal to negative 2 over 10, and x is equal to negative 10 over 10, and if we solve, we get the x is equal to negative 0.2, or x is equal to negative 1. So these values are basically the x-intercepts on a graph, and it's where the parabola will hit the x-axis. And since we have two values, we know that this parabola will hit the graph twice, which shows it has two solutions. Thank you for listening.